Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, today our topic is cement. In this, we will discuss what is cement. Then, we will discuss what are the major types of cement. After that, we will discuss different subtypes of cement. So, first of all, what is cement? Cement is a substance that binds, particularly a substance made of burned lime clay, sand and water to make the mortar or sand, water and gravel to make concrete. Students, in this point he said that cement is a substance which bind particularly a substance, and those substances which are made of burned lime, clay and sand, and water to make the mortar or sand, water and gravel to make the concrete. Cement is primarily characterized into two types. The first type is hydraulic cement and the second one is non-hydraulic cement. Student, hydraulic cement is that cement which is hardened in the presence of water, and non-hydraulic cement is a cement which does not harden in the presence of water. So students, in this lecture till now we have discussed cement is a substance that binds the substance which are made of burned lime, clay and sand, and water to make mortar or sand, water and gravel to make concrete. This is the definition of cement. Then we have discussed there are two types of cement. First one is hydraulic cement and then non-hydraulic cement. Hydraulic cement is that cement which is hardened in the presence of water, and then there is non-hydraulic cement, the cement which does not harden in the presence of water. So students, after this we will discuss one by one what is hydraulic cement, what is non-hydraulic cement, what are the properties of hydraulic cement, what are the properties of non-hydraulic cement, where the hydraulic cement is being used, where the non-hydraulic cement is being used. Now, the first of all, hydraulic cement. The cement which is hardened in the presence of water because of hydration, the chemical reaction between the cement and water. This type of cement can also harden in underwater. Portland cement is the best example for the hydraulic cement. Students, in this definition he said that hydraulic cement is that cement which is hardened in the presence of water. So there is a question in my mind, why it is hardened in the presence of water? The answer is that there is the hydration reaction between the cement and water. As this reaction happened, the cement is hardened in the presence of water, and as you know that hydration is the addition of water or the reaction of water with any compound. Here in this case there is the reaction of water with the cement. And the best example of hydraulic cement is Portland cement. Now, what is Portland cement? We will discuss it in the next slides. Now, the next one is non-hydraulic cement. The cement which does not harden under water is called non-hydraulic cement. This type of cement hardens when it reacts with the atmospheric carbon dioxide. This cement is resistant to attack by chemical after setting. Non-hydraulic cement is manufactured using non-hydraulic lime, gypsum, plaster and oxychloride which has liquid properties. So what he said in this definition? He said non-hydraulic cement is that cement which does not harden in the presence of water. This is the definition. Now, how that cement is hardened? Because hardening of cement is necessary. Non-hydraulic cement is hardened when it is reacted with the carbon dioxide, which is known as carbonation. So if anyone asks how non-hydraulic cement is hardened, then you can say that non-hydraulic cement is hardened when it is reacted with the carbon dioxide. This non-hydraulic cement is resistant to attack of different chemicals after setting. This non-hydraulic cement is manufactured by using non-hydraulic lime, gypsum plasters and oxychlorides. These three has liquid properties. So students, these were the two definitions of hydraulic and non-hydraulic cements. One by one we have explained. Dear students, till now we have discussed two major types of cement. The first one is hydraulic cement, which is hardened in the presence of water due to hydration, and non-hydraulic cement, which does not harden in the presence of water and it is hardened in the presence of carbon dioxide, or when it is reacted with the carbon dioxide, which is known as carbonation. Now students, we are going to discuss different types of cement which belongs to those two major important classes of cement. Now, different types of cement. By twisting the internal mixture ratio and by altering the chemical inputs, special types of cement can be produced according to the needs. Students, it means the production of cement depends upon our need. If we alter the inputs chemical, then we will have different type of cement. So the first type of that cement is ordinary Portland cement, which is pronounced as OPC. This is the most common type of cement which is extensively used. It has good resistance to cracking and dry shrinkage but less resistant to chemical attacks. OPC is not suitable for the construction work which is exposed to sulfates in the soil. Ordinary Portland cement is available in following types: 33 grade, 43 grade and 53 grade. The grade represent the strength of cement at 28 days. 33 grades is equal to 33 Newton per millimeter. So students, in the ordinary Portland cement, he said that this is the most extensively used type of cement. It is resistant to crack and shrinkage when it is dried. But OPC, ordinary Portland cement, is not suitable for the construction where there is the excess of sulfates in the soil. Ordinary Portland cement is available in different grades, and those grades are 33 grades, 43 grades, 53 grades, and the strength of grade or the grades represents the strength of cement. For example, 28 days, 33 grade is equal to 33 Newton per millimeter. So students, we have discussed ordinary Portland cement OPC. I'm going to repeat it again. OPC is most extensively used cement which is resistant to crack and shrinkage but it is not resistant to chemical attack, so we could not use it in the soil where there is a lot of or excess of sulfates. Ordinary cement available in different grades, 33 grades, 43 grades and 53 grades. Now the next one is rapid hardening cement. Rapid hardening cement is similar to ordinary Portland cement, which is pronounced as OPC. The early strength is achieved by excessive adding of C3S. C3S means tricalcium silicate, which is sulfate resistant in the mixture, and by lowering the C2S, which is dicalcium silicate, and it hydrates rapidly. Content in the cement. So students, in this point, he just said that rapid hardening cement is similar to the OPC, ordinary Portland cement. So if you increase the C3S tricalcium silicate content and lower the C2S dicalcium silicate content, then rapid hardening cement is formed. As the name itself resembling that, this type of cement is used where there is need for the high early strength. For example, pavement, busiest roadways, the strength of rapid hardening cement at the age of 3 days is almost the same as the 7 days of strength of ordinary Portland cement. It requires the same water cement ratio as OPC. This type of cement is not used for the massive concrete constructions. So students, in the second point, he said that as its name resembled that rapid hardening. So this type of cement is used where the early strength is needed. For example, the pavement, the busiest roadways. The strength of rapid hardening cement after 3 days is same like the strength of ordinary Portland cement after 7 days. In the rapid hardening cement and the Portland or the ordinary Portland cement, the ratio of the water is same. But the ordinary Portland cement is used for the massive constructions, but the rapid hardening Portland cement cannot use for the massive concrete constructions. So students, in this we have discussed just 2 points. First one is, if you increase the C3S and lower the C2S, then rapid hardening cement is formed. Then rapid hardening cement is used for the busiest roadways, and then we have discussed that rapid hardening cement has strength after 3 days like the ordinary Portland cement has strength after 7 days. The next one is low heat Portland cement. This type of cement is manufactured by lowering the C3S tricalcium silicate content and increasing the dicalcium silicate content. It possesses less compressive strength than ordinary Portland cement. It has less lime content than OPC. This type of cement is mostly used in the construction of retaining walls, and it is strictly not suitable for thin concrete structures. So students, in the low heat Portland cement, he said that if you lower the C3S and increase the C2S, it means if you increase the dicalcium silicate content and decrease the tricalcium silicate content, then low heat Portland cement will form. This low heat Portland cement has less lime content as compared to ordinary Portland cement, and also this cement is used for retaining walls and it is not used for the thin concrete structures. Now the next one is sulfate resisting Portland cement. It is manufactured by keeping the percentage of C3A below 5%. Now, C3A is the tricalcium aluminate content. If you keep the tricalcium aluminate content less than 5%, then you will get sulfate resisting Portland cement. This type of cement is used where the structure is prone to severe sulfate attacks, such as construction in the foundation of soil, marine condition, and sewage treatment tanks. So students, if there is a lot of sulfate presence in the soil and you want to construct your building on it, you have to use sulfate resisting Portland cement, and for the preparation of sulfate resisting Portland cement you must have tricalcium aluminate content less than 5%. You will get sulfate resisting Portland cement which is resistant to sulfates. So this was the sulfate resisting Portland cement and low heat Portland cement. So dear students, next one is high alumina cement. This type of cement has rich alumina content about 35%, which helps in gaining ultimate high strength within a short period. This type of a cement is used where a structure is subjected to action of seawater, chemical plants and furnaces. So students, high alumina cement is a cement which contain high percentage of alumina. It's about 35%. This alumina help this cement to attain ultimate high strength. This type of a cement is being used for the constructions which are subjected to the action of seawater, chemical plants and the furnaces. Now the next one is furnace slag cement. This type of cement is cheaper than ordinary Portland cement. It is manufactured by intergrinding of OPC clinker and blast furnace slag. Blast furnace slag cement develops low heat of hydration and has less early strength. So students, our next cement is furnace slag cement. He said that this type of a cement is cheaper than OPC. And now the question is how furnace slag cement is prepared. He said that if you grind OPC clinker with blast furnace slag, then this will develop furnace slag cement. And this cement has low heat of hydration, due to which there is less early strength as compared to OPC. So anyone asks, how can you prepare furnace slag cement? Then you can easily answer him. You can say if you grind OPC with blast furnace slag, then it will develop furnace slag cement. So students, these were two cements. High alumina content cement, which include 35% of alumina, and this alumina give it to ultimate strength. And next one was furnace slag cement, which is prepared by grinding OPC clinker with furnace slag, blast furnace slag. And this cement has low heat of hydration. Now the next one is colored cement. This type of a cement is also known as coalcrete. It is manufactured by adding coloring pigments 5 to 10% to the OPC. It is used where the colored cement is required for aesthetic purposes. It is used in joining tiles. So students, How can you prepare colored cement? You can simply prepare colored cement by adding 5 to 10% colored pigments into the OPC. It will give you colored cement. Now, this type of a cement is used for joining tiles. Is it clear or not? I'm going to repeat it. Colored cement is a cement which is produced or which is prepared by adding 5 to 10% colored pigments in the OPC. It will give you colored cement. Now, it is used for the joining tiles. The next one is pozzolana cement. This pozzolana is a material which is formed due to the volcanic eruption. It is a siliceous material having about 80% clay in it. Pozzolana cement is manufactured by mixing 30% of pozzolana to the ordinary Portland cement clinker. This type of a cement is used in constructions of dams and weirs. So students, what is pozzolana cement? So first of all, we are going to know what is pozzolana. So students, pozzolana is a material which is formed by the volcanic eruptions. After that, pozzolana consists of 80% clay. It is siliceous material. Now, how can we prepare pozzolana cement from pozzolana? If we mix 30% of pozzolana to the ordinary Portland cement, then it will give you pozzolana cement. And this type of a cement is used for the dams and weirs. So students, these were two more cements. First one was colored cement, which is formed by the addition of colored pigments about 5 to 10% into the OPC. It will give you colored cement. After that, there was pozzolana cement. First of all, we know that what is pozzolana? Pozzolana is a siliceous material which includes 80% of clay in it, and it is formed by the volcanic eruption. If we mix 30% of pozzolana to the ordinary Portland cement clinker, then it will give you pozzolana cement. And this type of a cement is being used for the dams and weirs. Now, next one is air entraining cement. This type of a cement is manufactured by adding 0.025 to 0.1% of air entraining agents to the ordinary Portland cement clinker. Air entraining agents are generally made up of wood resins, calcium agents, vegetable oils, and animal fats. It is used to fill up the gap in concrete which are produced by excessive amount of water during casting. So students, air entraining cement. Air entraining cement is formed by adding 0.025 to 0.1% of air entraining agent into the Portland cement or ordinary Portland cement clinker. Now, these air entraining agents generally made up of wood resins, calcium agents, vegetable oils, and animal fats. And these are used, air entraining cements are used to fill up the gap between the concrete which are produced due to the excess amount of water during the casting. So students, I'm going to revise it again. Air entraining cement is formed by adding 0.025 to 0.1% air entraining agents into the ordinary Portland cement clinker. Now, what are these air entraining agents? These air entraining agents are made up of wood resin, calcium agents, vegetable oils, and fats. These cements are being used to fill up the gaps between the concretes which are formed during the casting of cement due to the excess amount of water. Now, the next one is hydrophobic cement. This type of a cement is manufactured by grinding ordinary Portland cement clinker with water, oleic acid and stearic acid. These acids forms as a water repellent film around the cement particles which increase the shelf life of cement. The film around each grain of cement reduce the rate of deterioration of the cement during the long storage, transport or under unfavorable conditions. The film is broken out when the cement and aggregate are mixed together at the mixer, exposing the cement particles for normal hydration. Students, our topic is hydrophobic cement. Hydrophobic cement is found when ordinary Portland cement clinker is mixed up or is grind up with the oleic acid or stearic acid. These acids form a film around the grains of cement which protected from the decomposition, due to which the storage and the shipping become easy. So students, these were two more cements, air entraining cement and hydrophobic cement. Next one is white cement. This type of a cement is obtained by lowering the iron oxide content in the ordinary Portland cement. The strength and the durability is same as the OPC. This type of a cement is used for joining the tiles and other interior works. So students, white cement. Now the question is how white cement is produced. White cement can be prepared or produced by decreasing the iron oxide content into the OPC. When you have to decrease the iron oxide content OPC, then it will be the formation of white cement. This cement has same strength and durability like the OPC, and this type of a cement is used for joining tiles and the interior works. And the last type of Portland cement is waterproof Portland cement. This type of a cement is manufactured by adding small percentage of metal serrates in OPC during the grinding. This type of a cement is used in foundations, water tanks and other water remaining structures. So students, the last one is waterproof Portland cement. This type of a cement is manufactured when we add small percentage of metal serrates into the OPC during grinding. This type of a cement is used in the foundations, water tanks and other water remaining structures. So students, these were two more cements which we have discussed, white cement and waterproof cement. White cement is formed by decreasing the iron oxide content into the OPC, and waterproof cement is formed by adding the small percentage of metal serrates into the OPC during grinding, and waterproof Portland cement is formed. Dear students, till now we have discussed what is cement. After that, we have discussed what is hydraulic cement and what is non-hydraulic cement. Then we have said that by changing the input chemicals, we can increase or we can get the different type of cement. And we have discussed how by changing the inputs in ordinary Portland cement, we have prepared different types of cements, in which we have discussed pozzolana cement, hydraulic hydrophobic cement, and many more. Now we are going to discuss machinery which is involved into the manufacturing of cement. And in that machinery, the first one is excavators. Excavators are heavy construction equipment consist of a bomb, dipper, bucket and cap on rotating platform known as house. The house sits atop an undercarriage with tracks or wheels. They are natural progression from the steam shovels and often mistakenly called power shovels. Softer rocks are dug by the excavators. The next point is harder rocks are extracted by blasting. Harder rocks are extracted by blasting. Blasting is the controlled use of explosives and other methods such as gas pressure blasting to break rocks of excavation. So students, as you know that there are two types of rocks, softer rocks and harder rocks. Softer rocks are dug by the excavators. If there are harder rocks, then those rocks are first of all extracted by the blasting or use of controlled explosive. And the other method for the extraction of hard rocks are gas pressure blasting to break the rocks for the excavation. And the next one is trucks and dumpers. These are used for the transportation purposes. So students, in the machinery till now we have discussed excavators and trucks and dumpers. Excavators are being used for the digging of softer rocks. Then we have discussed the harder rocks are extracted by the blasting. And then we have discussed trucks and dumpers. These are being used for the transportation purposes. So students, this was the first lecture of cement in which we have discussed what is cement and its types, and then we have discussed the machinery which involved in the manufacturing of cement.